going to begin this lesson by talking about measures of center. Now, for this particular lesson, the measure of center that we're going to be focusing on is the mean. A measure of center is a single value that reflects the average value or the approximate center of a set of data. You can collect data from just about anywhere, and the middle of that data is often used to describe the set of data. Two of the most commonly used measures of center are the median and the mean. And like I said, in this lesson, we're going to be focused on the mean. To find the mean, we divide the sum of all the data values by the total number of data values. Here we have a dot plot of 8 test scores. You can see that the dot plot isn't very effective in describing the data. What you can tell from the dot plot is that the test scores range from below 40 to almost 100, but they don't really cluster together. You don't see a trend anywhere because there are no scores stacked up on top of one another. So the dot plot, this is what this says here, the dot plot shows the scores are spread out without any clusters, okay? So if we wanted to describe these test scores in a way, you may be familiar with your teacher saying what the class average of a test was. Oftentimes, if you hear the class average, you can measure whether or not you think you performed better than the class average or below the class average. And the class average is typically around the middle of all of the test scores. So it is useful to describe this set of data with a numerical value, like the mean, that reveals the characteristics of the data set. So if I were to find the mean of this set of data, I don't have to change the order of the data in any way because I'm finding the sum of all the data. And the sum of all the data is 521, and I'm going to divide 521, the sum of all the data, by the number of data points, in this case 8, and it gives me the value 65 and 125 thousandths. That means that the average test score, the mean test score, one of the measures of center of these 8 test scores is 65. Here is an example that you may run into, you may encounter an example like this if you're working on a section with measures of center, specifically the mean. The mean of 3 values, 32, y, and 56, is 47. Find the value of y. So it's not actually asking you to find the mean. It's expecting you to understand what the mean is and work with how you find the mean to find another piece of unknown information. In this case, we know that we add the 3 values together and divide by the number of values there are to get the mean. Because we are proficient in equation solving at this point, this should not be a challenge. I'm going to add 32 to 56 to y. Knowing that I can combine these like terms, I'm going to do so. 32 plus 56 is 88. Now I have this pink equation here. Y plus 88 divided by 3 is 47. But we need to solve the equation appropriately. So I'm going to undo the division of this expression, y plus 88, by multiplying by 3 on both sides. When I multiply by 3 on both sides, this side simplifies to leave me with 1 times y plus 88, which is just y plus 88 because of the multiplicative identity. 47 times 3, which I do to keep my equation balanced, is 141. Now I know that this unknown value plus 88 is 141. And that unknown value is 141 minus 88, which is the opposite of addition here. And when I do that subtraction correctly, I get 53. So let's think about whether this answer makes sense or not. I have 32 and 56 already, and then 53. If I wanted to, I could plug this value in find the sum and divide by 3, and I would in fact get 47. Okay? 47 is already pretty much in between 56 and 32. It's a little bit closer to 56 than it is 32, so it makes sense that this number is above the mean, because that mean is kind of like a balance point. Something that I'm always asked in class, what do I have to get, or what if I get a 100 on the next assignment? What will that do to my average? Well, this kind of algorithm here, this kind of equation, you can use if you already know all of your other grades, or the sum of all of your other grades. So I put this here. Understanding how the mean works, like in this example, can help you find out what grades you need to get on assignments to earn the overall average you desire in any particular class. Here is an example again. The mean height of 4 basketball players is 175 centimeters. The mean height of 12 soccer players is 171 centimeters. So we're being asked to find the mean height of all these players. First thing to note is if we are finding the mean height of all the players, how many players are there total? Well, there are 4 basketball players and 12 soccer players, so we have 16 players total. If we are finding the mean of 16 players, we're eventually going to be dividing by 16. So we're going to need a large number that is reasonable. And probably somewhere when we end up dividing by 16, we're going to want something that's around 170 something. I would be willing to guess it's probably between 171 and 175. Okay. So, if the average, the mean height of all 4 basketball players is 175, that means we got this number by dividing the sum of all of their heights by 4. So in order to find out the total of all of their heights, we just multiply it back by 4. Because I'm sure not every single one of the basketball players is exactly 175, but when we divided the sum of their heights by 4, that's the number we got. So to get back to the sum of their heights, I just undo that division that we know we did to find the mean initially, and that's 700 centimeters. So total, no matter what their heights are, I've got 700 centimeters worth of basketball player and 2,052 centimeters worth of soccer players, because there are 12 soccer players and their average height is 171 centimeters. So total, between the 16 players, I have 700 centimeters plus 2,052 centimeters. So between all, or among all 16 players, there's 2,752 centimeters of athlete. Now, because that's the absolute total of all of their heights, I can now divide by 16, and when I do that, I get 172 centimeters, which is the average height of all 16 athletes. And that is reasonable, because it's very close to their average heights already. Think about what this says about the heights of soccer players versus basketball players. There were only 4 basketball players, and there were 12 soccer players. Yet, when we added all of their heights together and divided, the average height increased for the soccer players. It's interesting, isn't it? I think so. We can also use the mean to compare 2 populations, meaning 2 groups of data, pretty much. Here I've got the height in inches of basketball players, and this is a completely separate example, not the same example from before. We're talking about something different. So I've got 10 basketball players, and their heights are plotted on this dot plot. I've got one 71 inches, one of them is 75 inches. Each of those red dots represents 1 player. So I've got 10 players total. You can see that their heights are pretty spread out. We've got someone who's all the way down to 71 inches, and some in a little cluster actually that are quite tall, 83 and 84 inches tall. And then I've got a dot plot of the heights of soccer players. Now notice they're not as spread out. They range from 68 to 74 inches tall. But they are quite a bit closer together, aren't they? Is it what you would expect? Well, we're going to find the mean of each of these. And how can I find the mean from a dot plot? Well, I would add 71 one time, because there's one dot, so that's one person who's 71 inches tall. 75, 78, 79 twice, 83 twice, and I would add 84 3 times. The sum of all of those heights in inches ends up being 800 inches. And there are 10 players. So when I divide 800 inches by 10, I get that the average height is 80 inches. And I'm going to note that right there. That is the average height of all basketball players out of those 10. Make note of how far away the average is from that tall cluster and from that shortest player. The same thing can be done to find the mean of the soccer players. I would add 68 twice, 69 once, 70 twice, 72 once, 73 3 times, because 3 players are 73 inches tall, and 74 once. The sum of all of those heights is 710 inches. And again, just like with the basketball team, there were 10 players, so I divide by 10, and the average height of a soccer player on this particular team is 71 inches, which I can note right there. Now remember that a mean is a measure of center. Do you think it's appropriate to say that the average height of this team is 80 inches tall? Which players do you think play the most often? Could that play a key role in how you describe a team's height? Maybe, maybe not. Sometimes the mean is exactly the information you need. Other times it's not exactly appropriate. It may be really appropriate here if that person who's 71 inches starts, but maybe they sit the bench the whole game. And if you are listening to someone who is broadcasting a basketball game and they tell you the average height, and that average height doesn't actually match up, or it's much less than the heights of all the players who you see playing, perhaps they could have used a better way to describe the average height of the players. Measures of center are not always, we don't always use the mean. So what does the mean tell us? What can we infer based on the mean? And does the mean tell the full story? I'll leave that for you to decide.